Hello everyone, this is Jason Edelman. Today we're going to take a quick look at leveraging Ansible for networking. I've written quite a bit about Ansible, giving some basic examples on Ansible itself and some different things other folks are doing in the community around Ansible. So here, I want to demo some pre-built custom modules in Ansible that I've created to help automate changes going forward on Cisco networking devices. Now here we have a small network set up, 3 routers, R1, R2, R3. There's some basic configuration on there left over from prior runs of this playbook, but you can see here the host name is router 1, host name is router 2, host name is router 3. There's some other SNMP settings on here, we can take a quick look at before we execute the playbook. But let's get into the router first, and if we look at, let's just take a look at your read-only community strings. So we can see there's 2 community strings, and this will be important as we go through the playbook. But just take note of that, and we'll come back to it later. So if we dive into the Ansible components here, first we have a host file. And as I've written about in the past, these are the hosts divided up into groups, however you want to divide them up. Here, this is one basic group of the 3 routers that I just showed, 10.1.1.110, and 120 and 130. And these are all put into the group called routers, right here. And if we look at our main Ansible playbook, that's titled neteng bff.yaml. Again, hopefully tools like this become network engineers' best friends, and then everyone can live happily ever after, okay? All right, but on a serious note, here we have a single playbook with a single play with 6 tasks. Each task is manipulating a certain change on each of these network devices. And if we go top down, these are pretty self-explanatory. We're going to be ensuring the host name is a certain defined parameter, a certain configuration, right? And so that this should really say ensure across the board, because one key point that I want to make here is in these custom modules, and the module name is host name here, the module name is enable secret and SNMP contact. These modules will not make a change to the device, and they will not execute commands if the device is already in the desired state. So if the desired state has the host name equal to X, and it already is X, the change will not be issued. So I should say that's the majority of them. Here, for example, enable secret, we may not be able to read the MD5 hash and then decipher what that is. So for our case here today, enable secret is actually being issued every time, where the other ones that are smart enough to go and gather the configuration, analyze it, and only make the change if the device is not in the desired state that we want that to be in. So we can look here in some of these modules. For example, if we look at update SNMP contact, SNMP contact is the module, and we're sending SNMP contact 2 key value pairs. The first key value pair is contact and then my name. So contact is the key, Jason Edelman is the value, and then device, inventory host name is the second key value pair. Now, one important point to remember is inventory host name is an Ansible pre-built variable, or built into this system itself, where inventory host name is the name of the host coming from the host file. So here, the inventory host name is just the IP address during each run here, and we're pulling in the IPs from the host name here. If it was a name, then it would be a name, right? But one other key point here, host name equals new host name. This is also a key value pair, but new host name is a variable, and these are stored in the host variable files within Ansible. So as a quick look, taking a look at router 1 at 10.1.1.110 has a single variable called new host name, and this is what we want the new host name of router 1 to be, okay? And R2 and R3 have similar files as well to have their host specific variables, where everything else is a standard. So if you consider this as 3 routers on across the WAN, we want everything to be the same, except the host name. So if we dive into the playbook here, we can execute the playbook, Ansible-playbook. We call the playbook name, and then we're going to include the -v to see the detailed output and messages being returned back to us during execution. So each task takes roughly 5 to 6 seconds because, again, I'm using one PK in the back end, and one PK just takes longer than I would like to connect to the device. If it was netconf, something like that, that's stateless, and that would be a lot quicker to connect to a device. What we can see here, host names are being changed. So something is being changed whenever this is in this yellow amber color, right? So we can see the new host name of the device. We can look at contact and location. These are green. So we can see here these changed or false. So nothing is being changed here, and I'm returning the message, no change required, already set. So we're not trying to execute a change on the device if it's already in the desired state. That's a very important piece to understand about Ansible. So again, read-only strings, rewrite strings, all of these are already in the desired states. All right, so we can look at 2 changed, overall 6 okay. And the 2 that changed were host names and enable secret. And if we want, for kick, just to prove it out, we had router 1 here, press enter, we see the new host name there. But if we do a show run pipe include read only, we see those 2 community strings that were there previously. So if we look at read only as an example, let's create a new read only string. Let's call it Ansible, and remove existing. Let's say we have the option now to remove the existing. So let's say remove the existing, yes. Let's save that file. It's the only change we're going to make right now. Let's go back to execute the playbook, and that should be good. Let's execute it. And again, so each time this task is executed, it's going out simultaneously to connect to 3 devices at once. So again, from a scalability perspective, so we have 3 devices and it's taking about 5 seconds to connect to each one. It's about 5 seconds per task. And that's only because it's one PK in the back end. If it was something else, this would likely be even quicker than it is. But we're making 6 changes times 3 devices, about 18 changes in about 45 seconds, which is still pretty darn good. So we're back to the read-only community strings here. I'll give it a few seconds here. And it's actually returning the existing that were already there. But we can see in our message here, removed existing entries and then added new entry. Right? So if we go back to the device, to router 1, the nice thing here is we remove the previous ones. We have the new community string called Ansible for read-only interactions to the device. And we can do the same thing with read-write. We can do remove existing, yes or no. Add the strings here, right? So the goal here was to show what can be done with networking with an open source, flexible and scalable platform. And these are 6 very small custom modules, but modules can be built for just about anything using any API in the backend as well. So hopefully this helps show what's possible with Ansible, and until next time.